Okay, so typically when we use classes in object-oriented programming, we have several instances of those classes active at once, and each instance might have different what are called instance variables. So if you think back to the idea of complex numbers, if you have different complex numbers have different real and imaginary parts. So you can have a whole bunch of different objects existing in this class of complex numbers, but they're all their own individual thing, but they all have access to all of the attributes of complex numbers. Okay, so let me just give you a basic example. And again, there's still some weird things. If you're accustomed to Python programming, there's some weird stuff going on here. I know that. I will adjust things as we go along here. So I'm going to say, I'm going to call my complex number z, and I'm going to say it's equal to complex numbers with a parentheses there. So now what this means, it means that z is now going to be a specific instance of the class of complex numbers. When I run this, nothing is going to happen. Okay, but being that it is a member of the class of complex numbers, I can do things like print z.a, and when I run this, oh, sorry, I just remembered I had set a to be a function earlier, so let me do this. And now if I do z.a, it's going to print out 5. Okay, if I do z.a is equal to 6, let's see what's going to happen. Print z.a. Now z.a is equal to 6. Okay, so let's go back. Let me do a couple of things. So if I run this, let's see what happens when I print z.a now. Okay, it's back to 5 because a equals 5 is a when I say z is equal to complex numbers, when I say z equals complex numbers with open parentheses, it creates what's called a particular instance of the class complex numbers. And there, whenever you run this, now it's going to set complex. Whenever it goes into this class, it's going to say complex numbers.a is equal to 5. And you can play around with trying to modify that in different ways and seeing what happens. Okay, now one of the things that we most like about classes is that z now has access to this function here. So if I do something like z.myFunction, I'll put the number 5 here. Now we're going to see what happens. We're going to see that there's going to be an error here. And I'll explain the error, but this would be an obvious thing to want to try here. z.myFunction, the expected output, if we were just doing this kind of naively, what's going to happen is you do z.myFunction. Python says, okay, I know what z is. It is a member of this class right here. There's my function there. So hopefully when we run this, it's going to say, hello world, you passed 5 as an argument. That would be what we would want. Okay. So I'm going to do this, and we're going to see what happens. Okay, so here we have an interesting error message. So complex numbers.myFunction takes one positional argument. So yes, it takes in one argument, but 2 were given. So if I come up here and see z.myFunction, there's only one argument there. But here it says the error that there were 2 arguments given. So the error is that Python's saying, I don't know what to do because you're passing in 2 arguments, but myFun only takes 1 argument. But what's going on here? We're only passing in 1 argument. Okay, so under the hood, what's going on here? When I say z.myFunction 5, what is happening is the following. When it does an instance of the class dotted with myFunction, dotted with one of these functions, what is doing? So let me just say once more. This line of code, that line of code right there, is equivalent. What's happening is that the following line of code is being run. Complex numbers, numbers dot myFunction, and it's passing in z and whatever the argument 5. So that line of code, so these 2 lines of code, z dot my function 5. What's happening is when Python runs this line of code, it says since z is a part of this class complex numbers, it's an instance of the class complex numbers. When it interprets this line right here, it interprets it exactly like this. And so it passes, it does complex numbers, which is the name of the class, dotted with the function, and it passes z in as a parameter to this function. So those are the two parameters. So when this line of code right here, when it says two parameters were given, or two arguments were given, one of the arguments is the object itself, z, and one of the arguments is what we wanted to pass in, which is 5. Okay, so if I want this code to work right, if I want this code to do the expected thing, in all class functions, which are called methods, in all methods, a function within a class body like this we call a method, we're going to pass in the parameter self. Slef would have worked, but self is the common name here. Okay, so now this function takes two parameters, and when you do something like z.myFunction5, this is going to pass in two arguments, one the argument z, and one the argument 5. Because again, this line of code, is exactly the same as this line of code. These are identical lines of code. I mean, they're identical lines of code in the sense that they do the same exact thing. Okay, so now I'm going to run this. So the reason I have that argument again is because I changed it up here, but to get this new class definition into this instance of Jupyter, I need to run it. There we go again. Okay, so now this is the type of thing that we expect. Okay, so the other thing is that when we create a complex number, what does a complex number have? It has a real part and an imaginary part. So really, when I do something like this, create a complex number, I need to somehow tell it what the real and imaginary parts are. And to do this, there's a special method called the init method. It's this format here, init, and it takes in, again, different arguments. Self is going to be 1, and I'm going to put the real part and the imaginary part. Okay, so now what we're going to do is we're going to say self.real is equal to real, self.imaginary is equal to imaginary. Wow, I don't know why I'm having a hard part there, or a hard time there. So I'm going to get rid of this because I don't really care about this anymore. And now what's going to happen once I run this line of code, okay, or once I activate this cell, so now there's a new definition of complex numbers inside Jupyter. When I do z is equal to complex numbers, what's going to happen is it's automatically going to call this method here. Self is going to be passed in automatically, but also the parameters real and imaginary. And so now if I want to make a complex number, I need to give two parameters here, let's say 1 and 15. And now what this is doing is when I run this line of code here, it's creating an object, which again is an instance of the class of complex numbers, and z will have real part 1 and imaginary part 15. So if I run this, everything should happen. And I can do something like print z.real, print z.imaginary, and I should get 1 and 15 when I do this. Okay, I can also do something like print z.a, and I'm going to and when I run this, I'm going to get 5 as well, because z is equal to 5. But now what I can do is I can have a new complex number. And let's say it's going to be minus 20 and 2. And now I can do the same thing, print w.real, print w.imaginary, and then print w.a. And again, when I print w.real, it's going to print minus 20. When I print w.imaginary, it's 2. When I print w.a, it's also going to print 5, because this is something, this thing right here, this a is equal to 5, this is called a class attribute, because notice it doesn't depend on a specific instance. It's called a class attribute, and what's going to happen is every instance of the class is going to have access to that attribute, and it's going to be 5. So when I run this, this is what I get. On the other hand, let's say I do z.a is equal to 17. Okay, if I print z.a, I'm going to get 17 there. But notice what happens if I print w.a, I also get 5. Or I mean, I get 5. Okay, so now these kind of weird inner workings of how objects can modify, how instances of objects can modify class methods, I don't want to get into that. It's way too tedious for what we're doing, which is very entry level, but all of that stuff is listed here. It's just something to keep in mind. Whenever you have an attribute like this, that is a class attribute and not tied specifically to an instance, unexpected things can happen, I guess is what I'm trying to say here. Okay, so let's introduce a function here. So what can we do to two complex numbers? We can add them together. So let's think about two different ways we can add complex numbers together. Let's think about not two different ways we can add complex numbers together. There's only one way to add complex numbers together. Let's think about how we can do this within code. Okay, so the way that we want to think about this, actually, before we add two numbers together, let's do something a little more basic. Let's compute the modulus of a complex number. So if I have a complex number has this thing called a modulus, and so a complex number should be able to compute its own modulus. So I'm going to define this new method, function modulus is going to take in itself, that's all. And now what it's going to do is it's going to return the square root of self dot the square root of the real part squared plus the imaginary part squared. So it's going to return math, that square root. We've got math imported here. Math dot square root self dot real squared plus self dot imaginary squared. And so I'm going to insert this. I'm going to make a new. So by the way, if you try to run this without any argument, you get an error here. Because as soon as if there is an init method in a class, whenever you do this line of code, it runs this method here and it passes in the arguments that you pass it. Well, self goes in by default, just automatically without you having to write it, and then you have real and imaginary. So this is expecting 3 arguments, but you're only passing 1, which is the okay. Okay, so now what we're doing is 2 and 5. So now this creates the complex number 2 plus 5i. So I'm going to run this, and now I want to print the modulus. Actually, would make much more sense to do to pick a Pythagorean thing like this. So 9 plus 16 is 25. Take the square root is 5. So if I do print z dot modulus, okay, if I print this, I should get 5, and I do, which is good. Let's look at something else. So if I just print z, let's see what I get. So maybe this isn't exactly what I want. Maybe I want to be able to print, in this case, it would be 3 plus 4i. So I'm going to make a new method called print, and it's going to take in self, and all it's going to do is it's going to return the string that is going to be this plus I times the imaginary part. So dot format, the first one is going to be self dot real, and the next one is going to be self dot imaginary. Remember what happens, it's going to return the string where instead of the brackets there, it'll be the first argument, which is self dot real, and instead of the brackets there, it'll be the second argument, which is self dot imaginary. I have to run this cell again to load this new class information into Jupyter, but now I should print z dot print. If I run this, this is what I get. And maybe print is not the right. I'm going to call this string instead, or to string instead. So I have this to string, and it's going to give the string version of this number, which is just 3 plus 4i. Or I had I4, but let me do it like this. I think this is probably more common. Of course, now none of this really matters to the overall point of the class, but this is what I'm doing. And then we can format this differently if we want. Okay, so that's what I'm going to talk about here. The next one I'm going to talk about how 2 different ways that we might implement the idea of adding 2 complex numbers together.